So you can think about the lead agent or an orchestrator as a CEO. Okay, I have to get a kettle, I have to heat the water, I got to get tea bags, I got to put sugar, and it has to be in certain brewing condition, and you have to brew it for a certain period of time, and then you add milk, and then you make the tea. But having said that, rest of the world is also seeing what can we do with our own innovation in this AI landscape, which is also changing very rapidly. If you have a small piece of module which you haven't actually written, but it's a legacy code, you can actually ask the AI to go and describe it for you, understand the functionality, understand its dependencies, and actually helps you to optimize some of those things. It's definitely lend you a hand. Okay, sometimes you got to pull the lever for sales so that we can bring in more money. You got to pull the lever in customer success so that the churn goes down. So it's not always the same kind of a paradigm, and it's not about pulling the levers. It's more about how much you have to pull.
Today, we are joined by Selva, who's the head of data science in Kowai.co. Selva has inspired me in my career in the understanding of AI back when we used to work together. When I discussed and decided on this topic of data science and AI, the first person that came to my mind was none other than Selva. Welcome, Selva.
Yeah, thank you, VP. Thanks for having me.
So, your career is interesting. When we talk about data science and AI, we talk about these things in the last 5 years, 3 years now, back after COVID. But then you've been doing data science for almost 20 years now. Can you walk us through that journey? Because 20 years back then, I'm not sure there was a lot of scope or there was a lot of awareness about data science and AI back then.
Yeah, look, when I started my career, and then I just started as an electronics engineer basically, and then I did my master's in La Trobe University, Australia, and that's when I got excited about data. But I was morely interested in, during those days, it wasn't called as data in my field, it was called as signals. So I come from a more on an engineering side of seeing data as a signal and a noise. There are a lot of algorithms out there in signal processing for this, like Kaplan filters, there are wavelet transforms. There are many techniques available to actually understand the data better. And then more importantly, how can we actually make this data usable so that an AI can actually take the data and then make inference out of it. So that was the idea behind doing those aspects. And then in my PhD, I got really into theoretical mathematics, and then I worked on a lot of filters based on wavelets, trying to apply them to image processing and stuff like that. Then what actually got me into this data science field was I was very passionate about data as such. I was more interested in data governance and data management, then really got into the application side of things. And my PhD career actually helped me in applying some of those things. You're right in the point that it wasn't called the data science during the time. It was more on signal processing. Machine learning was the term we actually used a lot. And then even before machine learning, people heard about neural networks. Neural networks was the hot topic when I was doing my PhD. And there are a lot of algorithms people talk about in machine learning, which was applicable, and I was more passionate about understanding the underlying algorithms. For example, think about a smaller algorithm such as decision trees, and I was more passionate about solving those nonlinear equations and things like that. So that's where it got me into these things. Again, now with all this open AI thing blowing up, and then the chatbots coming into play, there's a lot of interest in large language model, and suddenly instead of being machine learning, now people are actually talking about large language model, and natural language processing become a prominent kind of a paradigm. Back then, we are more interested in data as such, numerical data. But right now, I see a big shift in terms of people moving away from numerical data all the way to using text data and then using LLM as a paradigm to actually interact with AI.
That's amazing. I mean, your journey has been through a lot of ups and downs, if I can put it that way. Because you talk about signals, and then you move into understanding the data, and then massaging the data, for a lack of better word, and then moving to processing data in the best way you can. With OpenAI and all LLMs coming in, like you mentioned, we also see a shift in how the consumers look at AI tools as well, right? Having said that, that brings us nicely into the topic that we have for discussion today, which is more about agentic AI. So talk about agentic AI. What's the deal with agentic AI? How is it different from the traditional AI chatbots and all of that? Or is there any similarities around it?
Yeah, look, there are two terms that I just want to make sure we are clear in the definition. One is called agentic AI, and people also talk about AI agents. Okay, agentic AI is, when you think about agentic AI, you can think about just as a framework where it helps to build those AI agents. AI agents are the ones that is more autonomous software entity that can actually go and do things. Okay, so agentic AI is more of a framework. AI agents are the ones that is practically used in most of the applications. So that's the kind of a definition that I want to stick to. If you think about agents as a definition, agents are an autonomous entity, a software entity in which they actually think or plan, they take decisions, and then they go and execute that decision or the plan. Okay, that's very different to how a software has been built and been deployed.
Is that like close to an orchestrator?
Kind of a paradigm, yes, it is. It is more like a that kind of a paradigm. But having said that, what you do is, instead of giving an activity to an AI agent, what you now do is you set an objective, and it figures out how to get that objective done. Okay, that's exactly how the AI agents are actually being deployed in the real-time scenario, and that's what most of the people love about AI agents, because it gets things done for them.
Okay, you did mention about it figuring out how to get that activity done. So does that mean that there is a lot of decisions that AI takes in itself to be able to understand, what this task needs to be prioritized first, and then move forward?
Yeah. So what it actually trying to do is it's trying to reason, just like humans. So when I say go and make a tea, now we have to reason and then how to make a tea. Okay. We'll have to figure out, okay, I have to get a kettle, I have to heat the water, I got to get tea bags, I got to put sugar, and it has to be in certain brewing condition, and you have to brew it for a certain period of time, and then you add milk, and then you make the tea. Okay, that's the process we think through. Okay, that's exactly how an AI agent also thinks through. The moment you say I want a tea, it actually plans or figures out what needs to do. Okay, and then it makes important decisions. Okay, and then it actually goes and execute that plan basically on your behalf, so that you get things done at the end of the day. The most important aspect in AI agent is that you set an objective, okay, and the AI figures out to actually go and achieve that objective on your behalf. So that's the new paradigm that we are actually dealing with. It also resonates with a lot of thinking with the new kind of customer behavior actually seeing, because people are pressed for time these days. People don't have patience anymore. They want to get things done very quickly, and because AI agents are best suited for that. You set an objective, and I don't have to walk through any of the steps of a set of procedures. The AI does it on my behalf, and then actually gives me the outcome.
Okay. So in essence, the AI agents decide which automations have to happen at what point in time.
Exactly. So, for example, in any of those activities, actually plans, if it needs to call an API, it will does it. It will actually go and do. There's a concept called tool calling or function calling, and that's what an agent has in their toolkit. So whenever it needs something to accomplish, it actually calls an API, and then get the output, and then use it for the next set of downstream processes it actually needs.
That makes sense. So maybe we'll talk about just not one AI agent, but then there's this multi-agent AI or multi-agent systems, right? So when we talk about multi-agent systems, the way that I understand that is there are many agents involved, and based on precedence and based on how it understands instructions and processes decisions, each agents are called for a specific activity. Is that understanding fair assumption, or there are more to it?
Yeah, look, when you have multi-agent system, then you're not talking about one objective. You're talking about an objective which involves coordination with multiple different other agents as well. Okay, so basically so it has to be an orchestrator first, and basically you give this big set of complex objective to this orchestrator and actually figures out the plan for all the individual agents under it, and then actually goes and executes and then orchestrates everything and get things done. So that's usually how it actually done. The complexity increases as you increase the number of agents, okay, because it has to figure out who to tell what and then how to get things done. Okay, and then once it increases to a scale, it becomes a little bit tricky. And the most important thing is how would you evaluate whether the multi-agents are actually performing the way it actually are doing in the real-time scenario. That's the hardest part. People talk about evals a lot, and even doing evals on a small rack system is even is tricky at this point in time. But it's a solved problem. Doing it at agent level, individual agents, it's really hard. Doing it a multi agent, it's extremely astronomical kind of a complexity to evaluate because there is a lot of moving pieces around and there is no set framework in terms of testing this. So the evals are become more prominent, and if you are into building AI products, I think you should get into eval.
Okay. Yeah, you did talk about the evolution, and I recollect the days when we used to, run initial AI, projects, and then there used to be a lot of buzzwords that come up in meetings. I, as a project manager, I sometimes recognize a few of those, but not all of those. And one of those is the RAG models that you keep talking about a lot. So I'm trying to understand how does this RAG model play into all of these scenarios, and can you walk us through how does that improve the system holistically?
Yeah, look, when you talk about RAG, it stands for Retrieval Augmented Generation. So if you're talking to anything in chatting with chatbots like ChatGPT or Claude, basically it's a large language model. They train the large language model using the corpus of internet data, and its knowledge is very limited to a particular cutoff, a knowledge cutoff. Okay, anything that happened after the knowledge cutoff, it doesn't know. So a RAG is basically augmenting the recent knowledge with the knowledge that's already residing in the large language models. Okay, a RAG system typically goes and does a web search, or maybe it actually browses any of your knowledge-based systems and then augment a new knowledge, and then with the large language model they already have and produce a response. Okay, the way an AI agent actually uses is whenever it needs a particular knowledge which is not present inside their knowledge based repository, it has to go and reach out to the external world and then bring that knowledge. And that's exactly where the RAG system plays a role. So the AI agent has a comprehensive understanding about the topic, and then based on that, it can actually plan, reason, and then obviously take right decisions.
Okay, so it in essence is a testing model for the performance of the multi-agent systems. Can I put it that way?
Look, it's not more about testing. It's more about augmenting something with the multi-agent system. So whenever it needs new information it doesn't have, it actually goes and looks out. Okay. So that's where exactly RAG comes in. More on the aspect of new knowledge coming into the multi-agent system. That's exactly the role the RAG plays.
Got it. So when you talked about all these multi-agent systems, I'm struggling to understand if there is a lead agent of some sorts which takes higher precedence always, which then connects all these other agents together.
Yeah. Look, there's an orchestrated agent. That's where. So you can think about the lead agent or an orchestrated agent as a CEO. The CEO has a complex objective. For example, so grow the revenue of the company. So which means then he has to talk to the sales to bring in new revenue. He has to go and talk to some of the cost centers to reduce the cost. He has to go and talk to customer success team to upsell some of the products that they have, so that there is some kind of
revenue
coming in from the existing customer. Also, he has to reduce the churn. So if you think about it, so this is exactly a multi-agent would do in that case. When you have a complex objective like that, it actually understands that and distributes those kind of broken down sub-objectives to each of those agents so that they can actually execute on their own. Okay. So that's exactly how you can actually see as a multi-agent system.
I understand. So this particular orchestrator agent that we're talking about here also has data on what the SME of each of the other agents are.
Yeah, absolutely. So it has a knowledge on all the what the agents, each individual agent's capabilities are, what it can do, what it can actually accomplish, what it cannot. So that's why it's very important for the multi-agent system orchestrated to know the limitation of each agents and then probably get things done through them. Okay, so that's exactly what it actually orchestrates. That's why evaluating them is very hard. It's very tricky because there is no set rule for what to do. Okay, sometimes you got to pull the lever for sales so that we can bring in more money. You got to pull the lever in customer success so that the churn goes down. So it's not always the same kind of a paradigm, and it's not about pulling the levers. It's more about how much you have to pull. Okay, and if you think about that multi-agent system, that's exactly what's actually trying to do. It's not only dispersing all the objectives, it has a high level objective and it actually breaks down to sub objectives and then give it to each A agents to go and pretty much achieve that sub objectives. But at the same time, it has to be very cautious about the holistic view. Okay, that's very important. And the new paradigms are coming in. Again, the new frameworks are coming in the agentic AI world, whereby the orchestrator knows when to stop, whom to contact, and the most important paradigm is it also needs discovery. Okay, new agents can be added to this ecosystem, and as an orchestrator AI agent, it has to go and discover new services and new agents. That is also very important.
Interesting. We've been talking too much technical stuffs, at least, until the first 20 minutes of our podcast. But then I want to talk some real world examples so that our audience can relate to it better, right? So when we talk about agentic AI, can you give us some real world examples where it is being utilized currently, and how is its success being measured, and what's its way forward?
Yeah. So at the moment, the agentic AI is predominantly used in software development. If you think about the way the software has been built by the software developers is absolutely changing. They used to have requirements coming from a product manager or from a product leader, and then they actually translate that into a code. These days, they just need an artifact from the product managers. So they need PRDs, basically the product requirement documents, and that actually gives us what needs to be built. It actually gives a specification of what is the functionality it needs to have, where it should work, where it shouldn't work, what are the integration component actually have, and then you actually take that and then put it into an agentic AI. Okay, then it actually breaks down into the code level. Okay, what are the modules I have to build? What are the functions I have to build? What are the APIs I have to build? How do I need to structure my database for a new requirements? Okay, it actually does all the plan and actually present to the software engineer, and then they all have to do is just execute that. Okay, sometimes it's also called as vibe coding, and the vibe coding basically an agentic AI behind the scenes. So they have two modes basically. The first they call it as a planning mode where the AI, once you give the requirements, it actually asks a lot of follow-up questions so that they actually make sure there's no ambiguity present in the requirements. Then as a developer, you can also give some inputs. So once it's finalized with the document, once you read the document and you're happy, then you go into dev mode. And dev mode is where it actually goes and executes the PRD. It'll build the front-end code, back-end code, middleware, you name it. It'll build everything from end to end. So that's how people are being utilized. In terms of ROI, I think you're spot on. How do you measure it? I would measure in terms of productivity gain. If it takes about 2 hours to build a module, using an agentic AI, if it gets done in 30 minutes, fantastic. Then with that extra 90 minutes I've saved, I can go and do more work. Okay, so that's exactly how most of the companies are thinking about it. So you can actually think about it. The feature velocity for a lot of products will increase. Yeah, that ultimate goal.
Yeah, it does bring a smile to a lot of program managers' face, though. Having said that, I mean, you mentioned about the initial, planning, and then you go to the dev mode and then start building out what is required. While in the dev mode, does it also have the capability to help developers with some of the basic, coding expertise, like let's say error handling, exception handling, right from there to making sure that the code is, pretty, for a lack of better word, or it is aligned the way that it is expected, and it is also scalable that way. So does it help the developers? What I'm trying to ask is, does it help the developers with some of these so that they can build on top of it? It doesn't have to be completely AI, but then they could still interact with AI to better it.
Yeah, absolutely. Look, there are two ways to look at it. When you give it a code base to it, it actually analyzes your code base. It understands your design principles. It understands your coding practices, your naming conventions. It actually pretty much, the design language. And you're talking about design, you have something like a DDS, and then it actually complies with all those things. The amazing thing about is that you can put it on the dev mode and can actually do it autonomously, but it can also be an assistant. If you have a small piece of module which you haven't actually written, but it's a legacy code, you can actually ask the AI to go and describe it for you, understand the functionality, understand its dependencies, and actually helps you to optimize some of those things. It's definitely lend you a hand. At the same time, as a developer, I also need some freedom to write code. You don't have to rely on the AI. Okay, it's more of an assistant. If you want to go and put your 2 cents in, go for it. You can go still and write some of the codes, and then actually work with AI with the rest of the things, and then get the module.
Okay, so you did mention about the ROI, and the measure of ROI is using productivity, right? So should engineers be worried about their jobs now?
No, absolutely not. I believe that AI is more as a helping hand at the moment. Okay, it helps the developers to increase their productivity. Most importantly, the testing team also needs a lot of test cases to be written. They can rely on AI to build so that the product quality can be improved. I don't feel that AI is coming for most of the software jobs. I only feel that it's going to give them a bit of a booster rocket. If they're flying at some speed, the booster rocket helps to even go at higher speed. That's exactly what an AI is. AI is going to give you superpowers. The developers are going to be amazing in writing good software and then be extremely productive.
Okay. Not just the software engineers, right? It kind of changes the playing field for other roles related to product building as well. Talk about customer success and feedback management. We do have feedback management tools like example Canny or other feedback management tools, wherein there is constant communications or there is constant feedback coming into the tool. How does the product team make decisions on what to build first based on that? Right? And that's an interesting use case to start looking at how features should be prioritized.
Yeah, absolutely. Look, there are a multitude of channels in which the feedbacks come from a product team. It could be from Canny, where the existing customer puts in a request, through sales, marketing channel, and we also go to a lot of community forums and we hear a lot from them. And what you have to do is you have to use an AI to actually understand this data much better in a holistic way, and then that can be put into the backlog. And then as during the priority meeting, they can actually pick the right features to build. Yeah.
Okay, I'm just going to take a step back from all things AI from a theory perspective. And also, we spoke a lot on the technical side of it, to the landscape. We're talking about India, one of the best countries to hire software engineers and have products built. We've seen this trend for the past 25 years with India. Now, with the advent of AI coming in, with every industry and countries catching up, how is India playing into all these landscape? I know OpenAI is a system that was originated in the US, and then there is also a China-backed DeepSeek sort of a. Is that a tool?
No, it's more like a ChatGPT kind of tool. Yeah.
It's an LLM. What does India have, or is there any plans that we have right now to to focus on that?
Yeah. Look, if you look at from the holistic angle, most of the new technologies, they originated in Silicon Valley, basically from San Francisco, and rest of the world, they consume most of the tech. Starting from, you can name many pieces of technology. Okay, that's how originated in Silicon Valley. But having said that, rest of the world is also seeing what can we do with our own innovation in this AI landscape, which is also changing very rapidly. And China, they did DeepSeek, fantastic work in terms of building that model. with less cost, and it was a very super efficient model. And they did a lot of ground up innovation. If you read that paper from DeepSeek in terms of how they optimize a lot of this thing, it's fantastic work. When it comes to India as such, the government is actually investing. There's a one famous AI company called Sarvam AI. They're actually building an indigenous large language model pertaining to Indian languages. And they have a lot of cool APIs available, like voice to text, text to voice, very focused on the India's regional language and dialects. So those are the things, cool innovation that the Indian company is also doing. There are a lot of startups in Bangalore and in Noida. They're doing great stuff with building a lot of LLM-based products, and they're also building a lot of AI agents for the Indian market, which is a. And the government of India also invested a lot of things on GPU clusters, because to train an LLM model, one of the limiting factor is the compute. Okay, you need a lot of compute, and you need a lot of this H100 NVIDIA chips, and then advanced chips from NVIDIA as well to train this model, because it just sucks a lot of text data, and then you have to do pre-training and post-training. Based on some of the things I've seen, it actually takes about 6 months to release an LLM. Okay, there's a compute cluster running 24/7. That's a lot of compute. The government of India, they're actually investing in all this public infrastructure, and they're actually leasing out some of those GPU clusters for some of the innovative work to the startups, and then people who wants to build some cool things. I think that's a very fantastic roadway to innovate from the ground.
Right. I mean, we talk about the GPUs as well. That's another interesting area to get into. We saw early days of AI having, T4s, L4s, A100 chips used for all their, GPU intensive work. Yeah. But then, as things progress, H100 is now the recommendation from NVIDIA. Yeah. Now, what is its equivalent here in the Indian market? Do we have chip manufacturing companies down here in India that is something that could help the Indian segment, or is it something that the Indian government should be focusing on as well, in your personal view?
Yeah. Look, the semiconductor industry has always been a hot topic in India. We don't have a much bigger infrastructure in the early days, but the government is seeing as one of the a pillar for the growth, and they're actually investing heavily to have semiconductor manufacturing. Also, just not manufacturing, but also the real R&D work is actually happening. Most of the IP restricts with big companies like Intel, Qualcomm, Nvidia, and most of the world manufacturing is done by TMSC in Taiwan. Okay, and Indian government is actually understanding all these aspects, and they're actually doing some ground up innovation in India. They're setting up infrastructure, they're allocating funds. I think in the long run, we will catch up. Indians innovation will catch up with the rest of the world.
That's interesting. And when it does catch up, we know that our innovation is with quality, and it can serve a lot of members, because our ecosystem in itself is built for scalability. So it's good that way. Yeah. Now, I'm slightly digressing from that topic. I just want to understand the environment and eco-friendliness factor with respect to all these improvements, because sustainability is a huge factor nowadays. Yeah. So we talk about AI, agentic AI, and the way forward, but how does it all correlate with sustainability?
Yeah, look, sustainability has been a hot topic with the LLM community. To train all those GPUs, you need a lot of power, and then with all the power plants, of course, you have to cool down the cluster, and it takes a lot of heat from a lot of these researchers who are very focused on sustainability. Are we wasting enough? Are we wasting human resources, and then are we polluting the planet in terms of just to get an LLM done, give you a response? I think there was a tweet from Sam Altman that he's actually using some kilowatt of energy just to say thank you or things like that. I think it's a fact. To train the model, even there are a lot of people in Google done a lot of research in terms of trying to quantify that sustainability in a way that the innovation have to grow, has to happen, and there are now people are actually realizing that, okay, to build this LLM model, I need X number of GPUs. Now they're actually going into the optimization mode now. Okay, during the initial stage, it wasn't the factor, but these days people are more aware of what's the environmental damage they're actually doing by training an LLM, and they're coming up with sustainable ways. Okay, and I've seen big companies investing in data centers in a lot of cold countries where it's a naturally environment to cool down the clusters, and people are actually using innovative ways to cool down the cluster using new materials. So there's no carbon dioxide or carbon monoxide released to the atmosphere. Okay, and there's no emerging cost from burning coal and things like that. Okay, so they're definitely looking at new ways to do ground up innovation in the infrastructure layer. Okay, how they train this LLM model, all the GPU clusters and stuff like that. Definitely, there are a lot of work that's been done.
Interesting. Young generations will definitely take a look at that. And having said that, another topic about the young generations is that how is the Indian student community catching up to all the latest innovations? And I know you have a lot of youngsters in your team that you're working with right now. How do you feel is the quality of output coming from colleges, and are they ready to fight in this ecosystem to
Yeah, look, from my perspective, when I go and visit all the colleges and then go to a lot of the universities, people are actually using this Chat GPT, Cloud tools very much. They're all integrated. People are actually abandoning Google and then go into this, which is a good thing in my perspective, because they're actually using Chat GPT and Cloud as a learning tool. I've seen a lot of people learning new concepts, use it for a lot of programming, so they don't have to. They're more interested in building things now. That's very good from a college student perspective, because they are actually emerging talents and they have to be nurtured. At the same time, they're also losing a grip on what has been done in the old ways. Okay, they're sometimes I also feel that they're also losing a little bit of thinking in terms of coming up with the logic, because AI taken the front stage and then doing it for them. So there's a bit of a balance. But having said that, the students these days, they build a lot of cool projects. They put it on GitHub. They build a good portfolio for themselves so that they can actually showcase to all the companies. I think the hiring model is also shifting. There'd be days where the companies go for a campus interview and then hire students. But these days, the companies the best talents have been handpicked. Okay, given that GitHub is your portfolio to the world, if you're done some really cool projects and people are actually seeing it, they're actually going to hire you. Okay, absolutely, absolutely. I fundamentally feel that there are also acceleration in a lot of GitHub profiles being created in India, and because the student community has actually been doing a lot of projects and showcasing them as well. There are a lot of ground up innovation they can actually do. In fact, contribute back to the ecosystem as well.
Absolutely. I'm sure that the Indian students who are watching this podcast will definitely benefit out of the conversations that we just had. It's been a wonderful conversation, Selva. Thank you so much for being here and sharing your knowledge with our community. We'll meet everyone with another podcast soon.
Okay, thank you.